Welcome to Faculty Focus, the podcast of the Faculty of Pharmaceutical, Biomedical and Veterinary Sciences of the University of Antwerp. I'm Teun de Voegt. And as always, Marleen Eijkmans is joining us today. Good morning, Marleen.
Hi, good morning.
In research talks, we meet with researchers from our faculty and discuss their latest research. For this episode of Faculty Focus, we're going to talk about the chemical safety of novel plant-based foods. Researchers Alissa Makan Schönleben and Fatima den Ouden, both PhD researchers from the Toxicological Center of the University of Antwerp, have recently published a paper in Environmental Science and Technology in which they investigate the safety of novel plant-based foods. Welcome to the podcast.
Thank you. Thank you.
But before we dive deeper into the science behind it, let me welcome you to my kitchen. So on Mondays, it's just me and my 4-year-old son. And for dinner, we cook up some veggie wraps. We have some grated carrots, a bit of chopped cucumber, pieces of tomato, avocado, some kidney beans, and of course the super convenient pièce de résistance soy-based vegan meat. Oké, wat wil je er allemaal op?
Veel komkommer.
Komkommer, worteltjes, avocado.
Kijk op de worstel.
Ja, avocado.
Ja, ik vind tomaten niet zo lekker.
Ah, ja. Zijn het lekkere wraps?
Veel lekkerder dan een koeienvlees.
So Alicia, after reading your research, quick veggie wraps no longer seem like a good idea. Or are they?
So basically what we found in our paper was that you can definitely still eat these kind of products and they're not posing a danger to anyone. So it's absolutely still safe to eat these kind of products. You can give them to your son as well. But maybe not every day, and it should not be the only thing you eat, basically. And that's due to different reasons, but one of them is also that they're very most of those products are ultra processed.
What are novel plant-based foods?
Yeah. Okay, so novel plant-based foods are new kind of products that have entered the market a few years ago. So these are basically alternatives to conventional animal-based products, but they're plant-based. So that means they don't contain any animal products. So for example, fish, meat or cheese, but then you have like the plant-based alternative to that. And basically they intend to mimic the characteristic of all these kinds of food. So you want the texture, you want the taste of meat, but you don't want the animal products in it. But to reach that kind of product, then you need to start, like if you start from a soybean or chickpea or something, the food needs to undergo substantial food processing. So you can imagine you start with like this soybean and you want it to look like like meat, then you need to change the original food quite a lot. So you need to basically extract the proteins and disassemble them, and then you reassemble them into a completely new shape. And you also have to add additives for the taste, the texture. So, for example, flavors or colorants or thickness. So they are basically most times ultra-processed foods.
And how do you know when you go to the shops? How do you know when something is ultra-processed? From which point is food ultra-processed?
Yeah, that's a bit tricky, I think, especially with the novel plant-based foods. There's a debate going on now, but basically if you look at the ingredients, so if you see it's a very, very long list of ingredients that you wouldn't find in a normal kitchen, like with words that you can't even pronounce, then that's probably an ultra-processed food. And they also have like long shelf lives usually, and also if it doesn't resemble the original whole food anymore.
Okay.
So you have like the candy or the soda or ready-to-eat meals are also ultra-processed food. Yeah.
So those novel plant-based foods are mostly found in category 4 of the NOVA classification system. Can you explain this system and the scale?
So Nova classifies food based on their processing.
Mm-hmm.
So it's important to mention it's not a system based on nutritional value. So it does not mean that one class has more nutritional value than the other, but it really looks at food processing. So in the first class, you have normally more unprocessed food. So it includes fresh fruit, fresh meat. Then the second class is more processed ingredients, so oil and butter, because they are made from one ingredient that's processed. And then the third category is more processed food, so it can be a vegetable, but then in a can, because you add things to make it last longer, or some bread and cheese. And then the last one is the category 4, the ultra-processed foods. And this includes foods that have undergone more heavy processing. So indeed, the novel plant-based foods are here, but you can also have normal meat products, such as chicken nuggets. Of course, they are made from normal meat, but it's not a fresh meat anymore. It undergoes a lot of steps to get to the chicken nuggets, but also some chocolate, chips, all these products are ultra processed.
There is no difference in that category. It's just one category. It's all together on one pile.
For now, if you follow these guidelines, yes, maybe indeed if you go to nutritional scientists, they have already made more
division.
But the
on,
proposal for now was this.
was this one. Okay. So what are the most important chemical classes associated with food processing, and what are they used for?
So we've seen in previous studies that there are certain compound classes that are more associated with food processing. We don't necessarily know exactly how or why yet, but that's just something that they've observed in previous studies. So we saw that's the case for plasticizers, for organophosphorus flame retardants, and also for chlorinated paraffins. So we didn't look at this compound class in this study, but yeah, that's also something that we're still investigating. And basically these compounds are additives, or they're added to materials for different reasons. So if you look at the flame retardants, as the name already says, they're used in materials to make it more resistant to fire. And then the plasticizers are added to plastics to make it more elastic, more durable, more flexible.
Yeah,
Yeah.
right. And how do they end up in our food then?
Yeah, that's a
$1 million question.
Yeah, that is a good question. Like, we don't really know for sure. There's different hypotheses that we're having. So, for example, again, we think it could be the food processing. So, from the materials that we use in the food processing. So, we use also plastics, for example, or rubber, like the conveyor belts where the food is transported. But also it could be leaking from the machinery. So, like the lubricants
Doesn't sound
used
good.
there. No, it does not sound good. We could just see it's the case, like that we find these compounds, but we cannot really say how, because we didn't follow the whole processing. We don't know where they enter and how and why. And another source could also be the food packaging, so the food contact material, for example. So also that's used either during storage or also later where they're stored in. Yeah, so this is how they can end up in the food.
Mm-hmm. And can you tell us a little bit more about how you carried out this research? How did you find all these contaminants?
Yes, so basically what we did is we just went to different supermarkets and we just bought a lot of products.
She says with a big smile on her face. It's a nice day out.
Team building.
Food shopping, you just buy the products that you're interested in. Mm-hmm. So we did that. So we bought products in Germany, Belgium, and the UK because these are the biggest markets in Europe right now. Basically just bought everything that's kind of representative of what the people are eating. So which of these products. And then we analyzed those products for the compounds that we're interested in. And for that, basically what we do is we want to extract the compounds that we're interested in, while at the same time also removing things that we're not interested in. So, or things that would actually like disturb our analysis. So the fats or the protein, for example. And then once we have like a nice and clean extract, we can inject that into liquid chromatography coupled to mass spectrometry. So that's a very typical tool in analytical chemistry. and then you can analyze the compounds you're interested in, and you can measure the concentrations basically in the food. And then once you have those concentrations, you can use them, you can compare them to other studies, you can also you can do statistics with them, or what we did was we did an exposure and risk assessment in different dietary scenarios. So that means you look at how exposed we are to these kind of compounds, and also what kind of risk is coming from that. And we also collected the food packaging, and then we also analyzed that to see if that could be a possible source.
Okay. So you put the novel plant-based foods just in the blender, mixed it up, and then analyzed it?
I wish. So the procedure takes about 8 hours, I think.
For one sample?
A bit shorter?
No.
No, you can do around 20 samples at the same time.
Okay.
And then you just walk through different steps where you remove the things that you don't want and you extract the compounds that you do want. But no.
Because you want to end up with a cleaner sample, because if you analyze them as they are, you find a lot of interference with your analysis, so we clean up a bit first.
Okay.
A bit, yeah.
And I read in your paper that you don't use electrical mixers.
Yeah.
And why is that?
We generally don't, because there again, it's possible that they introduce some contamination, so of the compounds that we're interested in. So for example, there could be, I don't know if that was the case for these compounds as well, but for other compounds that there could be the lubricants that are used as well, or also then, if it's also plastic again, then I can introduce that as well.
So I use an electric mixer in my kitchen daily. Do I contaminate my food?
Well,
possibly, yes.
We don't know.
Possibly, yes.
They have to see the mixer.
They have to see the mixer. Yes.
Analyze before and after. As we are scientists, we can only say if we have data.
I think for these compounds, I don't know if there were studies, but I know for other compounds there were actually studies with the electrical blenders, and you do introduce more contamination.
Okay.
Good to know.
But again, it's difficult. You cannot avoid all of these sources.
Of course. Yeah. Okay.
Yeah.
Can you tell about the fact that the plant-based cheese alternatives, they have the highest level of contaminations, but why might these cheeses be particularly affected?
So the thing is, in our studies, most of the cheese samples we collected were made out of coconut oil. And in general, if you go to the supermarket, most of these plant-based cheese products are made out of coconut oil. So we've seen that these kind of compounds accumulate in more fattier food. So in general, in other studies, so in like normal conventional food. So we think that this, might be a source in the plant-based cheese as well, because it was the most fattiest samples, because they're made out of oil. But we also don't know how exactly the compounds end up in the cheese and why. So it's possible that they're already in the coconut oil itself that's used as an ingredient. But it's also possible that they accumulate later and that they're just more prone to accumulating due to the fat content. So we don't really know yet, but it was definitely interesting.
Indeed. I didn't know that coconut oil was a substantial basis for cheese.
Yeah, for the plant-based cheese, definitely. And that's also the thing, it's so different than the other products, because they're mostly based on like soy or peas, like just generally vegetables or pulses. But the cheese is, based on oil.
So you also use different types of diets where you looked at in your study. How did you categorize it? What's vegetarian for you? What's a veggie for you? What criteria did you use?
So the problem with this was that there are no really clear defined dietary patterns right now. So there's different suggestions, but there's no like commonly agreed upon
general agreements.
Yeah, so the definitions are like not that strict. And also we did not have consumption data on these kind of products. So that was a bit of a problem that we had to find a solution for that, because we still wanted to have the different exposure scenarios to see, so we can make better statements. So basically what we did is we started with a worst case approach. So that's commonly done in science. You say like, okay, this is the worst case. And then if that is safe, then the other like lesser cases can also be considered safe. So we said that a vegan would consume 100% of these products instead of animal-based products. So instead of meat, fish, cheese, we substituted 100% plant-based meat, fish, cheese alternatives. for the vegan.
Mhm.
And then we said based on that, we would say a vegetarian would eat these products maybe like 3 or 4 times. So instead of meat, they would eat these things 3 or 4 times per week, because they still eat cheese and eggs and maybe even fish. So then we had like the 50% for the vegetarian. And then we said a flexitarian maybe eats it 1 time per week. So instead of meat, they say, okay, today I'm going to eat the plant-based chicken instead of the normal chicken. And then, we said this is like the 10%. So basically we wanted to have a large variety of different exposure scenarios and different dietary patterns, just so we can see, what are the differences. And that was due to the lack of real clear definitions and consumption data.
Okay, that's clear.
Definitely.
And so pesticides are everywhere, and Europe has approved new alternative for toxic pesticides, but for now there's still not enough data to know what the long-term impact on our health could be. Are we always 2 steps behind?
Yeah, this we found a difficult question because we are not regulators. And as I say, as scientists, you want to look just at the data that we know things about and not to speak about other people's expertise.
Okay.
But I understand this is the idea that many people have, but it's not so easy, I think, to speak about, because there are now some ideas that instead of looking at single compounds, you look at the compound class, so that if you find, okay, one compound is toxic and should not be allowed, that you say, but then the others in the group might also be toxic, so let's ban all of them. But in this way, we are scientists and we always look at, this is bad. But in a way, you need flame retardants, no? If you don't want your mattress to catch fire, if we want nice plastic things, you need plasticizers. So it's also not so easy to just say ban everything. So I think this is a whole debate on itself.
So maybe a follow-up question on that, a little bit more into the domain, I guess. How do the levels of flame retardants and plasticizers in the novel plant-based foods compare to those found in traditional animal-based foods?
Yeah, so this is, we think, an important question. Because first, it was difficult to find other studies to compare it with.
It was very new, your study
yes,
design.
So for sure to compare with other novel-based food, it was difficult because there are some studies that included those products, but then it was only one food group with 3 samples, for example. Like they would investigate the whole human diet, and one group is meat substitutes, but they also look to milk, to everything, basically what we eat. So then you only have a small sample size, so it's difficult to compare. And second, if we look at studies looking into meat, it will just write meat. But we don't know what were the meat products. Is it fresh meat? Is it chicken nuggets that I already mentioned?
Sausages.
Yes, so we don't know what are we comparing with. Because if we compare these novel-based plant foods with fresh meat, it's not really actually an honest comparison, because we should look at processed meat and these processed vegan products. So that's why it may seem like, they are much worse than meat, but that's not actually what we're saying.
No, it's not really investigated yet.
No, we just say, we find higher levels compared to what is reported in meat. But to have a real comparison, we should actually compare with processed meat products.
Another trip to the shop.
I don't know if I would say it like that, because now we looked at, we couldn't compare that's true, and would be really nice if you could compare the processed meat, then the unprocessed meat, and then our products compared to that. Because what we had now was usually an average of processed meat and unprocessed meat.
Yeah.
So I don't think I would like to compare our food to only processed meat, because when you use these novel plant-based foods, you also substitute the normal unprocessed meat. So you would just, if you would go to the butcher and buy a chicken, and then instead you use the plant-based chicken version, then you're substituting a non-processed food with a processed food. So I think it's also important to compare that, and to still keep it also the unprocessed meat in the equation.
There's still a lot of research to be done
Yes.
Yeah,
to
definitely.
get like a baseline of what is all the definitions of the diets.
It's very new.
Yeah.
And you have to actually look at the complete picture, what you eat in total, not only...
That would be really nice if we could just have like a a full diet or also like a full vegan diet, for example, and then we can really make proper statements. So this was a first study on the contamination in these kind of food, but there's much more needed, of course.
And do you guys eat novel plant-based foods?
I do, yeah. I'm
Yeah.
not vegetarian, but I do eat them still because some of them are actually really nice.
Yeah.
Like
I
I
agree,
eat
I
meat
agree.
as well, but sometimes like some of the vegan ones are really nice, so I also eat them.
Yeah.
Which is
Yeah, they are very nice. That's the thing. Like of course.
And convenient.
Yeah, super convenient.
Yeah.
And also, of course, we're saying now some negative things about them, but in general, they had a lot of positive effects as well, just like positive societal effects, because people are switching more to these kind of products. So instead of eating meat, they're also eating this, and in the end, it is more sustainable. So that's also something it's just a good development, and they're putting like the plant-based diets more on the more in the spotlight, because you can see, okay, they're not just boring. This is not just like super bland food, like, I don't know, 10 years ago or 20 years ago, but it can actually be very nice and tasty and fun.
A lot of effort has been
Yeah.
put in the taste of those products,
Yeah,
probably.
which is also a good development, but
It's good for the mind shift for people who don't want to eat a lot of meat, right?
yeah.
But you could also just eat the vegetables and the other products.
because we are not saying the study is not about vegan diet in general. It's only about those products that are eaten normally more by vegans, of course.
Yeah.
That is true. Those contain some higher levels.
Yeah.
But
But it can help to make a mind shift in people that are always eating meat because it's so convenient, it's so tasty.
Yeah.
They can see.
Yeah, absolutely. So that development is really good, and they did.
Yeah.
They put a lot of effort into this, the industries, and those improvements are really nice, because in the end we need to reduce our meat consumption, and we need to change these aspects for a more sustainable food system. So in that regard, it's a great development. A balanced diet is the most important thing. So you can definitely include those products. We did not find any danger coming from them. So they're not posing any health risks. All were below the levels, because we did actually look at the risk and did a risk assessment, and we saw that for all the compounds, they were definitely below the levels that pose a risk if you eat them. So that's really very important to stress.
Yeah. What is the take-home message you have for our listeners?
Basically, the take-home message is that you can still safely eat these kind of products, but maybe not all the time. It should not be the only thing you eat, in moderation, but basically everything should be in moderation. And what's important is that people should be aware that plant-based does not necessarily mean that it's like the healthier and the better option compared to animal-based food. So that's in general, but also based on our study, because there is a substantial amount of food processing involved in novel plant-based foods, so in the production of them, and that just makes the products more prone to chemical contamination. But we should also mention that same applies for other ultra-processed foods, so it's also the case for ultra-processed meat. But people should just be aware that these products are largely processed and that can introduce chemical contamination.
What brings the future for your research?
Yeah, one thing we did not look at yet, which would be very interesting, are the plant-based drinks, actually. Because we only looked at the solid food, but we did not look at plant-based yogurt or milk alternatives.
And the soya milk.
I have to invite you again to my kitchen then.
Because those are really, they're even bigger, I think. Like, they have even a bigger share of the market, and everyone drinks them.
And already longer, for a longer period of time.
Yeah. So it would be very interesting to see. And then, it would be nice to have like real consumption patterns of these kind of products. Yeah.
And also, if you really want to know where the contamination comes from, you should also investigate, maybe the machinery they use, the gloves. But I think it's outside our project.
Yeah, but it would be very nice to see.
But for future studies, if they manage, it would be really nice to really have an idea where it's coming from.
Of course. Yeah. Thank you very much.
Thank you.
Good luck with
Thank you.
with your research, and thank you for coming by.
Thanks. Thank you.